essentially the practice labs for your certification, for your PC Pro certification. So these ones are pretty important. So please, once again, I'll reiterate, pay attention a little bit. But let's start off with our computer selection video.
In this lesson, we're going to discuss component selection. When you're selecting components, your goal is to ensure that a PC system has all the equipment it needs to function. The first step is to conduct a needs analysis. A needs analysis identifies who will use the computer system and what they'll use it for, so you can purchase the correct equipment and avoid expensive errors. So who does this involve? Well, there's the end users who will use the new systems. Ask how they will use the systems and what applications they need to do their jobs. Note the system requirements for each application. Check with the end user's manager to find out what he or she expects. Many times, what the end users tell you isn't really what the manager had in mind when the systems were requested. Stakeholders also include the staff that will be responsible for supporting the system after you have implemented them, and the individuals responsible for authorizing the funds to make the purchase. Make sure you document everything you learn from the stakeholders, because you'll need to distribute a finalized needs analysis to all stakeholders and ask them to sign off on it. Doing this ensures that all parties know what the scope of the project is and acknowledge it. If there are concerns, it's better to resolve them at this point in the process rather than later on after the new equipment is purchased and installed. Let's look at several common workstation implementations and discuss the considerations you need to keep in mind when you're installing each type of system. If your needs analysis indicates that the end users need workstations to create graphics, 3D models, or CAD/CAM drawings, then you should keep a few things in mind. First, you'll need a workstation with a very powerful processor. Implement the most powerful processor available that fits within your budget. Obviously, a 64-bit processor with multiple cores is most appropriate here. 4 cores will likely be the minimum acceptable configuration. Using a 6 or 8-core processor would be better. This system will also require a very high-end video card with a fast GPU and a lot of memory. Onboard video embedded in the motherboard will not be fast enough. The applications running on this type of workstation also require a great deal of RAM. Check the specific memory requirements for the applications your end users will run. Then add 25 to 50% more to ensure there is extra capacity for the future. If anyone at your organization creates or edits audio or video files, you'll need to implement an audio-video editing workstation. A 64-bit processor with 6 to 8 cores is best for this system. Video editing applications need a lot of RAM. Check the specific memory requirements for the applications your end users will run. Then add 25 to 50% more to ensure there is extra capacity for the future. For video editing, you'll also need a very high-end video card that can handle at least 2 monitors. For a video editing system, you need a really good quality audio card. Depending on how the system will be used, you might need a high-end external audio interface that's capable of mixing and processing audio from multiple sources. Video files tend to be very large, so you'll need a big, fast storage device. Many video editing systems use a very large standard hard disk drive for long-term storage and a smaller, faster SSD drive to store files as they're developed. Your organization might also need a hypervisor for virtualization. A hypervisor can run multiple virtual machines simultaneously on the same physical hardware. It will require a great deal of computing capacity. Each virtual machine running on the system will require processing time from the CPU. As with the previous systems, a 64-bit processor with 6 to 8 cores is best. Hypervisors require a lot of RAM. The more virtual machines that run concurrently, the more system RAM is required. Virtual machines also require a large amount of very fast storage space. Because of this, multiple SSDs are commonly installed in this type of system. A gaming PC requires a powerful processor. As usual, a 64-bit processor with 6 to 8 cores is best. You'll also need a high-end video card with a specialized graphics processor to help out with the graphics processing load. And a quality audio interface with surround sound is best. Lastly, make sure you have enough memory to support the games that will run. For a home theater system, 64-bit processor with 2 to 4 cores is adequate. A high-end video card is required. and a quality audio interface is the most appropriate. Your storage should include a Blu-ray drive. A thick client system is probably the most common PC implementation. End users run desktop applications on it to complete day-to-day tasks. Generally speaking, this type of system needs to meet the software requirements for a processor, memory, and storage to run a locally installed desktop operating system, like Windows or Linux. A good rule of thumb is to exceed the minimum operating requirements by 50% to prepare for future capacity demands. A thin client doesn't need as much computing power as a thick client. A thin client connects to a server over the network and displays the desktop of the server on the local system. The local system doesn't really do much, so it just needs to run basic applications and establish the network connection. The remote server does most of the processing. This can be accomplished with most operating systems, especially Windows and Linux. In terms of hardware, a thin client only needs enough computing capacity to get the operating system up and running. A home server provides services that the end user consumes from a workstation. A home server needs to have a lot of RAM installed depending on how many services the system will host. Home servers are frequently accessed over a network connection, so they need to have the fastest network interface that the network infrastructure supports. In a home environment, this will probably be a gigabit Ethernet connection. Adequate storage is also required. To protect data and improve performance, you may want to consider using a RAID array that incorporates striping with either parity or mirroring. In this lesson, we talked about how to select components for a particular type of PC system. We discussed the importance of a needs analysis. Then we looked at the hardware requirements for a graphics CAD/CAM design workstation, an audio-video editing workstation, a hypervisor, a gaming PC, a thick client, a thin client, and a home server.
All right, so all of those little specifications or parameters to choose peripherals are very important. So just keep a note of those, and some of the labs will go over some of that, but make sure you're making notes of that particular information. Excuse me. So we're going to go into two labs now, kind of drawing from that information. Okay. So the first lab is in chapter 10.3.3, prepare disks for installation. All right. So basically we're going to look at disks that are physically installed and then use the instructions and descriptions of the lab to configure them to be ready for usage. So we work at a computer repair store and we want to use the RAID, R-A-I-D. So who can tell me what RAID stands for in the IT world, not in the bug killing world? What is RAID? Speak up. Anyone? Are you guys, is everyone still there?
Redundant array of inexpensive disk.
Okay. Who's that? Ralph?
Yes.
Thank you. All right. Yeah, redundant array of independent disk. You will rarely hear it spelled out that way, but you really need to keep in mind disk installations and RAID. You will see that a lot in the IT world. All right. So we want to use the RAID feature on the motherboard to configure two RAID arrays. We've installed 5 new SATA hard drives in our computer, we've installed Windows on the first drive, which is pretty common, and we want to use the other 4 drives for our RAID arrays. And RAID arrays can be used for several things: storage, processing, application, high-end functioning applications, etc. So in this lab, we're going to configure the array from the SATA drive mode, define the first array as LD1 is going to be a striped array, and then the second array is going to be LD2, is going to be a mirrored array. One quick question: who can tell me the kind of the basic difference between RAID 0 and RAID 1? That's what these are: a striped and a mirrored array. Just a brief comparison of the two. Who can tell me that?
How many disks you need, right?
That's one. So how many disks? 2 or more. So what's the other very basic difference between the two?
I
Speed.
think 0 is the processor.
Speed depends. And what was that, James?
0 is processor.
Oh, 0 is striped. And well, one of the basic,
Mirroring.
yes, one of the basic differences is that striped is usually an extension of 2 or more drives, whereas mirrored is that. You're just essentially mirroring the drives for redundancy. So they're copies of one another. And you'll see that a lot too. So remember that stripe is an extension, mirrored is essentially like a copy. All right, so let's start the lab. And in the new version, you can actually view all of your last scores, but we do want you to continue to take the labs until you pass them 100%. And please do that for practice purposes. All right. So our computer is off and on our little workbench. We want to go into what area to configure our RAID. Do you all remember that?
BIOS.
BIOS.
BIOS. Yeah, you guys are on top of it. So make sure when you boot, you hit the delete key, or if you have an F2, but the delete key will work as well to take you into the BIOS of your configuration on your PC or on your system. And within the BIOS, you want to expand the system configuration area. And in the system configuration, you do have a SATA operation. Click on that, and it gives you the choices to disable it, normal, what we would call normal process AHCI, and then RAID and ECP. We're not going to go over these a lot, and you don't really need to know these. Generally, in the IT world, it's either the disabled array or the RAID is on. So we'll make sure you turn that or select the radio button to turn the RAID on, because this will give you the opportunity to configure the RAID arrays. And make sure you apply or save and then exit. Now this will take you to your disk operating functionality. So make sure you prepare yourself to do a Control-I when your disk operation appears. So this will take you into configuring your RAID if you have the RAID on. If the RAID is off, then it'll go right into right to your desktop. So once you hit that Control-I, now we're ready to configure or create our RAIDs. So basically, we start with 1, create a RAID volume, hit enter. It takes you into the configuration menu to create the volume. And our first RAID is going to be defined as LD1. So we will have to type that in. LD1, uppercase. Let's follow the instructions, although case doesn't really matter here, but I'm just being detail oriented. And it defaults to RAID 0 or striped. So it should just hit enter or return, and then enter again to move down to the disk selection item. And so to select your disk, just hit enter. It will show you all the disks that are available. Now you want to use your arrow key to move up and down. And we're gonna select drives 1 and 2. They're all the same size, but it doesn't really matter. We're just gonna be organized that way. So to select a drive, as you see in the instructions, the arrows to preview next, the space to select the disk, and enter to finish. So hit the space for disk 1. Remember, we're not going to select disk 0 because that's our operating system. Windows is already installed on there. We're going to keep that a non-RAID disk. If we select that, then it will erase our OS. And then arrow down and select disk 2. So we have both disks. They're both 800 gigs or so, and we're doing a stripe. So the amount available should be around 1.6 tera. So then we hit enter when we're done. Now, here's the tricky part. I mean, if you hit enter again, it'll just take you back into to configure the RAID. So you have to tab to the next item, and the arrow key will not work here. So you tab down to your next item, and you see that it does give you suggestions or recommendations for the different arrays. RAID 0 is 128K for your strip size, and it's just an allocated part to make sure that it configures the RAID as stripe. So we hit enter there, and yes, we're using the maximum amount. It will default to the maximum amount of available disk space as far as capacity for the drives, which is once again 1.6 tera or 1600 gigs. So just hit enter, and then it'll take us down to our create volume or create RAID selection. So we hit enter. We get our little warning that this RAID will be created and everything on the disk will be lost if we have anything, but we know that these disks are just essentially allocated for this array. So we select Y for create. And so you see here that we have disk 1 and disk 2 are now a part of RAID 0, remember disk 0, remember disk 0, okay? All right, so for our second RAID, we want to create a mirror. So once again, we want to select create a RAID volume, and we want to name it LD2 according to our instructions, enter. Now you can use the arrow key, the up and down arrow key, to select your RAID. We want a RAID 1, which is mirror. Make sure you select the mirror, and then hit select again, or enter again, and then enter. So you notice that the disks that we use for that RAID 0 are not showing, which is good. That's a good thing in the BIOS, the new BIOS. You don't have the opportunity to destroy a RAID that you've already created, although you still have the opportunity to kill your operating system, so don't do that. So once again, arrow down, spacebar to select, enter, and then tab. And you notice that our maximum amount of space for our RAID 1 is 800 gigs. And as I said before, it's just basically creating a method to have the information copied to each drive. So if one drive goes bad, the second drive will take over the operations. So check to make sure there's no one waiting to get in. A moment. No. All right. So 800 gigs, enter, create the volume, yes. So as you see, all of our 4 disks are now part of an array. 1 and 2 are a RAID 0, 3 and 4 are now RAID 1, which is what these digits in the parentheses represent. All right, so now we just hit 6, hit the number 6 to exit. Are you sure you want to exit? Yes. And this should take us to our desktop. All right. Now, we're done with the lab, but let me ask you all, what's the best way to check? How can we check our disks to make sure they're ready for use? What's the best method? There's several ways to do this, but what do you think?
Disk manager
Disk manager. We'll go to disk manager.
or disk management.
It's device manager.
Oh, device.
And then device manager, you have your disk drives. And you see that we have our operating system drive and then our two RAID drives, LD1 and LD2, right? And if you click on them and bring up the properties, you can see that basically it'll define, in general terms, how these drives are configured. So that's probably the best way to take a look at, to make sure the drives are available. The device manager is always your friend as far as checking your system. So let's go ahead and score it. Good job. And that one is pretty important. Go ahead, Carol.
Oh, it's Stacy.
Oh, Stacy, go ahead.
So I know that you created the RAID straight out of the BIOS system. Is that because that one is for the motherboard in particular? Because I know you showed us another way to make a RAID.
Right.
When I first did this lab, I did it the other way.
Which is actually fine. Even though it states that it's a motherboard array, either way will create the RAID for the motherboard because it involves.
Okay, so technically, like if we were actually in a working environment, then we could do it either way.
Right.
Okay.
And what I'll state, sorry for interrupting. Generally, you want to create the RAID long before the operating system is installed. So you won't have the opportunity to go to the device manager method to do it.
Okay.
You generally will be doing that in the BIOS.
Okay. I was just confused because when I done it the other way, it obviously, and I scored the lab, it said it was wrong, even though technically it was all there.
Right.
So I was just double checking if you could technically do it or whatever.
Yes, you can. And I'll say again, this one was specifically pointing you towards the BIOS configuration, which, yeah, you can do it both ways.
So when we do the testing, we should always make sure that if there's any hints within the instructions.
When you do the testing, please follow the instructions. The cert that's a part of the cert. It's based on, are you actually, even though you may know alternate ways to perform some of these actions, which there are, but specifically, I would definitely follow the instructions. If it's asking you to go into the BIOS, you should be in the BIOS, period.
Jane.
Go ahead.
Question. After selecting the disk, what will I press to go out? Is
Pardon?
it F6? After selecting the disk, those
No,
disks?
you just hit enter. Or wait, where are you?
After I'm done with the disk, the 1, 2, 3, 4.
We don't know where's the tab is.
I'm not sure where you're at, James.
He's referring on the BIOS to exit.
The BIOS, yeah. To exit.
6.
Just hit 6, the number 6.
Oh, number 6.
It'll give you a prompt asking if you want to exit, and then you can exit.
Okay.
Okay.
Thank you.
Welcome. All right. let's continue with our second lab. That's 10.3.5. And this is just installing the workstation image using PXE. PXE is a method, and we're going to view. Please review the notes, but just to let you know, PXE is just another way of installing an OS on your system if it's available, basically. And you'll see during this lab, you just have to link to it, and the OS will install. And this is usually the way that most large corporations have their IT department install OSs on several systems. They just log in as administrator and they launch what we're going to go through right now. So you're an IT admin for a small corp. The computer in Office 2 recently failed, which happens, and you replaced a hard drive. So you would like to download and re-image the workstation from the network. And this is what it's much faster and it's actually more secure to do it this way. If you work in an IT department, basically you just have to know this process. I mean, you'll probably do this many, many times just to make sure the OS is installed. So we're going to turn on the computer, and remember, it does not have an OS. So we're going to configure the integrated NIC, which is your network card, in the BIOS for PXE, boot the computer, and Windows should install. All right. Let's start that. All right. So remember this, we just put in a hard drive. So we're going to begin the operating system of the OS installation. So go ahead and turn it on and go right into the BIOS. All right. And if you look under your system configuration, there's an integrated NIC, which is your network adapter, basically. And we're going to enable with PXE, which all PXE, and if you take a look at the information on PXE, it just enables a direct connection to either network or cloud-based drive, where all it does is launches an installation or launches an image, or essentially loads an image. So we want to enable with PXE. Select that radial button, apply, and then go ahead and exit. And generally, this is all you need to do. If you are logged in as an admin, it will start the PXE boot, which basically says you're connecting to that IP address, which is usually a gateway, which is also connecting to a server. And these are, generally you'll have a list of OSs there. But we're going to install Windows 10, 64-bit. So we just hit enter, and it starts to load the image with the OS. And it's much faster too than a regular Windows installation. It is truly this fast. It'll take 10, 15 seconds because you're not actually installing it. It's just adding this whole image right to your drive. And so now, yes, here we are in Windows that fast. So we know that we have it installed. We know we can check the File Explorer, or you can check the system, go into the system, the Windows settings, scroll down to the system settings, scroll down to About, and you see that we have our device name, our processor, and Windows 10 Enterprise 1709 version. And that's a good thing about, and basically, when you do something like this, it will load everything that was on that system before it went down, because generally PXE will create a restore point automatically, either it will create a restore point, or in most cases you just have to install whatever that image is, which is probably just a base Windows image. And that's, depending on how your PXE is set up, and how the administrator, the system administrator is working with the environment, you may have the opportunity to save everything that you've worked on, but hopefully in those scenarios, you've saved things either to the cloud or to some external drives or whatever. Because in many instances, yes, it'll just load the OS and nothing else. So none of your work will be saved. So be careful with that. Any questions?
Does that mean also certain applications can transfer or just the OS?
Yes, well, it depends on whatever the default image is. And usually the companies will have approved applications. And for the most part, as an individual worker, you won't have the opportunity to install anything anyway. That has to be approved by the administrator, by the company administrator. So all of the company-related applications will be added with that image when it's restored. Does that make sense?
Yes, that makes sense.
Okay. Any other questions? All right. So I forgot to score the lab, but yes, we did complete it. So let's go on to our next video, which is, always fun keeping this organized. 10.3.1. Which will actually give you an explanation about Windows installation and PXE. Maybe I should have shown this. I never know, first off, how applicable the videos are. But yes, this one will offer a more detailed explanation about Windows installations and selecting a scenario that has an image, etc. All right. Okay, here we go.
In this lesson, we're going to review the process for performing a clean installation of Windows. While the actual steps for installing Windows 7, 8.1, or 10 will vary, the overall process is very similar. First, you need to consider which storage device you want to install Windows on. There are several options to choose from: an internal hard disk drive, external hard disk drive, hot swappable internal hard drive, internal solid state drive, external flash drive, or an internal or external RAID array. Each type of storage device has its advantages and disadvantages. For example, standard internal hard disk drives are relatively inexpensive, provide ample storage space, and provide reasonable performance for their price. However, they're not as portable or as fast as other types of storage devices. External hard disk drives are relatively inexpensive, provide ample storage space, and are very portable. However, their performance is limited by the type of interface used. For example, a drive connected to a USB 2.0 interface will perform very poorly due to the interface limitations. Using a faster interface, like USB 3.0, will provide better performance. Hot swappable drives can be added or removed from the system while it's running. However, they require a specialized motherboard and are much more expensive than standard internal hard disks. Solid-state drives provide excellent performance. However, they are much more expensive and tend to provide less storage space than standard hard disk drives. External flash drives are very inexpensive and portable. However, they don't typically provide the same degree of performance as a standard hard disk drive. Like an external hard drive, they are also limited by the interface they're connected to. Using a fast interface like USB 3.0 will provide better performance. RAID arrays provide ample storage space, excellent performance, and can provide data redundancy if configured to do so. However, they're also more expensive and require a degree of expertise to configure. They also usually require specialized software drivers to support the RAID interface in the system. If you're using an internal hard disk drive, then you don't need to do much other than ensure it's connected and functioning properly. However, if you want to install Windows on a hardware RAID array, then you must configure it before you start the installation process. To do this, first, connect all the storage devices to the motherboard or to the RAID controller board. Second, configure the RAID array using the appropriate utility. For onboard RAID controllers, this is typically done using the BIOS or UEFI setup program. For add-on RAID controllers, you usually press a certain key sequence when the system initially boots and the board's BIOS is loaded. Next, you need to determine how you will install Windows. There are many options available. You could choose to install from a traditional optical disk. In this situation, you will need to configure the system to boot off of the optical drive first. You can also install from an external USB drive. This option tends to be considerably faster than installing from an optical disk. If you choose this option, you need to configure your system to boot from an external USB drive first. An easy way to make a USB installation drive is to use the Windows 7 USB DVD download tool, which is available from Microsoft's website. You can use it to copy a Windows installation ISO image, which can also be downloaded from Microsoft's website, to a USB drive or a blank DVD. In an enterprise environment, you could elect to use a network install. To do this, you would configure the system to boot from its network interface. This is done using the pre-boot execution environment, or PXE. During a PXE boot, the system connects to a Windows remote installation server over the network, loads a minimal operating system, and begins the installation process from a shared folder on the server containing the installation files. This option tends to be slower than a standard local install. However, it works very well in situations where you need to install many systems all at once. Another installation option is to use disk imaging. Using disk imaging, you install a base Windows system on one computer. Then you use a disk duplication process to copy that system's hard drive to the hard drives of other computers. Imaging is much faster than the traditional Windows installation process. However, there are several considerations to keep in mind before using this option. It's best suited to situations where you need to install a lot of computers at once. You can simultaneously install as many systems as your network bandwidth can support. Because of driver support issues, imaging works best when the hardware on the destination systems is the same as the hardware on the reference system. This option works best if a volume license was used on the reference system. If a standard license was used on the reference system, then you will have to relicense each imaged system. A final option would be to use an unattended installation. In an unattended installation, you run through the installation of Windows on one computer. During the installation process, you create a file that contains all of your responses to the questions that are asked by the installer. Then, you use that response file as you install Windows on other computer systems. This allows the installation to proceed without your intervention. You can also use a Windows To Go installation, which is available in Windows 8 and later. Windows To Go allows you to install the Windows operating system onto a USB flash drive. To boot the system, you plug the USB drive into a USB port of the system and configure it to boot from an external USB drive. When you do, the Windows operating system is loaded from the USB device instead of an internal hard disk drive. When you boot the system from the Windows installation media, it will initially load a file named boot.wim into RAM. This file contains a scaled-down operating system called the Windows Pre-Installation Environment, or Windows PE. Windows PE is used to temporarily create a minimal Windows system in RAM that will be used to facilitate the rest of the installation process. Let's walk through the steps that have to occur in order to complete a clean install of Windows. The first thing you have to do is accept the Microsoft license agreement. Depending on the version and edition of Windows you're installing, you may have to supply a product key. Next, you need to specify what type of installation you want to complete. Two options are presented: upgrade and custom. To perform a clean install, you need to select a custom install, not an upgrade. It's kind of misleading because there's no installation option labeled clean. Remember, a custom install is used to perform a clean installation. Then you need to specify which disk you want to install Windows on. Select which disk you want to use. You have two options. Select the unallocated space you want to use. If you do this, the Windows installer will automatically partition and format the space for you. Manually create and format the partitions where you want Windows installed. If the storage device you want to install Windows on is not shown, then the Windows installer probably didn't have the necessary driver to support it on the installation media. This commonly happens when installing Windows on a RAID array or a SCSI hard disk. In this situation, you need to select Load Driver to manually load a device driver. This should allow you to access the storage device and install Windows on it. Next, a Windows image is copied over from the installation media to the storage device. This takes some time to accomplish. Once done, you need to personalize Windows. You specify things such as the color theme that's going to be used, the computer name, and a wireless network if a wireless network interface is installed in the system. Next, you specify how the user will sign into Windows. In earlier versions of Windows, there were two options for logging on. You could either use a local user account or a domain user account. With Windows 8 and later, you can use a local account, a domain user account, or you can use an online Microsoft account. Using an online account has many advantages. You have access to apps provided by the Windows Store. If you don't use a Microsoft account to sign into the system, then you can't install apps from the Windows Store. You can sync your personalization settings and files between multiple computer systems. Your user profile can follow you across systems. In this lesson, we discussed how to install Windows. We discussed how to select an installation type and how to complete a clean installation of Windows.
All right. Any questions about Windows installation? Well, unfortunately, I would like to show another video before we go into our virtualization labs, because it is very useful, and I should show this before. And then we'll have 3 labs on virtualization, and then we'll take a break, and then we'll go into our networking, our packet tracer networking scenario for the evening. Okay, Ariel's finally here. All right. No questions about Windows installation? And he stated that the PXE, or the external scenario, is just usually used to create an or to load an image. Depending on how many applications are on that image with the OS, that's usually what takes the longest. But generally, it's something that's relatively fast compared to like a CD or DVD install, or even a USB install. Because Windows will take, I don't know how many of you have actually installed Windows on your systems?
Never.
Never? Well, if you go into IT, you will experience the adventure. And it's much easier now because most of the drivers are set and et cetera. But one wrong click during the installation process, or let's say you lose your battery power on your laptop during the middle of the process, the installation will become corrupt. And basically you'll have to do it all over again. And usually that will impact your hard drive, and it can become kind of a frustrating mess. But, all right. So anyway, let's go ahead and watch this video on it. It's just a general overview of virtualization. We will go into speaking about virtualization and what that means. And
Oh, Dwight, but James.
go ahead, James.
Yeah, by the way, like if in case you want to assemble a computer, like for the motherboard, what will I look for the motherboard?
What do you mean?
Like how does it go? Look for a motherboard first before installing the others, like the hard drives and everything?
Well, yes, and we went over that in the PC fundamentals. Motherboards are, depending on where you want to start, if you're building a computer from scratch, usually it comes with a kit. You generally will not, especially if you're building a PC, for the most part, you order the kit, which comes with the case and the motherboard and all the specifications with that motherboard. Unless you find something really old, which I don't recommend, because that can just drive you nuts, because there's just so many things that can go wrong. I would, if you're thinking about building a computer, I would definitely stick with the mini kits that are out there that are available.
So okay, so if you're gonna make one, there's a kit. So then just follow the rest then.
Right, and unless, well, you'll probably see this if you work in an IT shop, if you're just, just a novice user interested in building your computer, to be honest, it's not really worth it anymore, because one, unless you're just wanting to do that because it can be a hobby or whatever. But for the most part, I mean, unless you have, well, I guess we do have a lot of time on our hands now. But for the most part, most of the computers that are out there now, you'll have enough time putting on peripherals and things like that, adding memory. The core level is really not that, challenging per se. But building the computer from the motherboard, that's probably the most challenging. Adding hard drives.
I see.
I have a question regarding the Windows and the different kinds there is, like enterprise, business, home.
Oh, wait a minute.
Is there a big difference?
Hear you. Hold on.
Can you hear me now?
Okay, go ahead.
Just questions between the Windows, the whole enterprise, business, home edition. Do those make a big difference overall on how, per se, they can behave?
You're talking about the Windows versions, correct?
Yes.
Yes, they do. The basic home, you'll run into limitations, especially if you want to run high-end applications. It will not have the back-end engine power to do that. Now, the Windows 10 is great. Most of the home versions you won't run into any issues. And generally on your home PC, you're not going to be running high-end applications, but you will run across corporate systems where they're running Windows 10 Enterprise, where it's absolutely necessary because of the applications that they're running. So there is a huge difference. There's kind of a big jump between home. There's a Windows 10 Education, which is an abbreviated version of Enterprise, and then actual several versions of Windows 10 Enterprise.
So like a network management software, would that be run on a business type of machine?
Yeah, and network management will not be run on a PC. It would be run on a server, which is a whole nother ballgame. Those are not. When you say network management, are you talking about home or business?
More in the business.
Yeah, that would be on a server. It would be a specific high-level application running from a server. That's a good question, though, because there's actually Microsoft did a relatively good job with Windows 10, because the off-the-shelf version that you purchase on your PC from Best Buy or wherever, and then the Windows 10 Home Basic Edition is actually pretty well suited for most applications. Specifically, all the Microsoft suite of applications, you won't have a problem. It's generally it's those proprietary applications that you'll see in industry that you'll have issues with. Your home PC will be fine with Windows Home. Although with the work from home scenario, I guarantee you that you will probably be recommended to do some type of upgrade from Windows Home off the shelf, if that's what you're running. Yeah, all of my systems are running Windows 10 Enterprise because it provides the most support for any level of application. And it really doesn't matter what your how much memory you have, or what's your, your processing speed or whatever. There is essentially the communication between your OS and those hardware devices that essentially build the application speeds and performance. That's a very good question. All right, good. Okay, so let's go ahead and go into our next video, which is virtualization, which is another very, very, very important topic in industry. And you'll see. So we're going to do our virtualization overview.
Let's spend a few minutes talking about virtualization. In the traditional computing model, there is one operating system installed on each physical system. These three boxes represent the hardware in a PC system. In order to use these hardware resources, an operating system must be installed. The operating system's role is to provide mediation services for all the applications running on that device. For example, it manages access to hardware resources such as the system RAM and CPU for the applications running on the system. This single instance of the operating system has full reign over all the hardware resources available in the system. This computing model can be very inefficient. The operating system doesn't fully utilize all of the available hardware resources in the system all the time. This is particularly true on a server system. Most of the time, the computing resources are underutilized. That means resources are available to perform computing tasks, but are not used, and capacity is wasted. For example, suppose you have 3 servers running in the data center, and each server is running at about 10% utilization. In this situation, 90% of the available capacity of each system is not utilized. This wasted capacity represents wasted money. In this example, 90% of the hardware investment in each server system is not used. It also represents wasted electrical power. Each server uses about the same amount of electricity to run, regardless of whether it's utilized 10% or 50%. It's also wasting the power it takes to cool the machines. There are 3 systems generating surplus heat that has to be removed from the data center. You can improve this situation using virtualization. Virtualization allows us to consolidate multiple operating systems onto the same physical hardware. To implement virtualization, you must employ a special type of operating system called a hypervisor. In this diagram, you have the same hardware resources in the computer as we looked at earlier. But instead of installing an operating system directly onto that hardware, we install a special type of operating system called a hypervisor. A hypervisor has some characteristics of a standard operating system, but it doesn't provide all of the features and functionality that you would normally associate with an operating system. The hypervisor's key role is to manage access to the CPU, storage devices, network interfaces, and RAM. Hypervisors also support VLANs. A VLAN is a virtual local area network. In this case, an external virtual switch binds to a physical network adapter and connects the physical network to a virtual one. VLANs let you partition a single switch network without having to run cables or make changes to the current network infrastructure. On top of the hypervisor, you can create virtual machines. Virtual machines act like physical computers, but they're not. They're emulated hardware devices created and managed by the hypervisor. The hypervisor allocates each virtual machine a certain amount of CPU time, storage space, and RAM. Because they emulate physical computer systems, you can install an operating system within each virtual machine. In fact, the operating system can't tell the difference. It thinks it's running on a physical system. You can install whatever operating system you wish within each virtual machine, as long as it's supported by the hypervisor. In this example, we could install Linux on one virtual machine and Windows Server on the other 2 virtual machines. Here, we've imported the 3 physical servers we looked at previously into virtual machines running on the same hypervisor. Remember, they were previously running with an average utilization of about 10% each. By consolidating them onto the same physical hardware, we've increased the utilization of the hypervisor system to an average of about 30%. That still leaves plenty of available utilization for periods of high demand. If one virtual machine suddenly experiences a spike in utilization, resources can be dynamically reallocated from low utilization virtual machines. This configuration uses physical resources much more efficiently with less waste. There are several different types of virtualization that you should be familiar with. The first is called full virtualization. In full virtualization, the virtual machine completely emulates a real physical host. Full virtualization is useful because it allows most operating systems and applications to run within that virtual machine without being modified in any way. However, it doesn't provide the same level of performance as other types of virtualization. There's also partial virtualization. In partial virtualization, some of the VM components are virtualized, but some are not. The operating system uses some virtualized components along with some physical hardware components. An operating system can only run in a partial virtualization environment if that operating system has been specifically modified to do so. The last type of virtualization is called paravirtualization. In paravirtualization, the hardware is not virtualized at all. All of the virtual machines running on the hypervisor directly access the hardware resources in the physical system. None of the components are virtualized. To accomplish this, the virtual machines run within isolated domains on the same physical hardware. For an operating system to run a paravirtualization environment, the operating system has to be specially modified to do so. There are two general types of virtualization platforms that you can choose from when implementing virtual machines: client-side and server-side. Client-side virtualization requires virtualization software to be installed on the desktop client itself. In this configuration, the workstation runs the locally installed desktop operating system, such as Windows or Linux, as well as guest operating systems running within virtual machines. Client-side virtualization has several advantages. No extra hardware is required as long as the system meets the recommended virtualization software system requirements. The virtualization software is usually easy to install and run. The virtualization software is usually less expensive than other solutions. Some are even free. But client-side virtualization has some disadvantages as well. It tends to provide poor performance because the system hardware must run the locally installed operating system, as well as all of the virtualized guest operating systems. With client-side virtualization, features usually aren't portable, so virtual machines can't be moved from physical host to physical host to provide load balancing and fault tolerance. Commonly used desktop virtualization implementations include Oracle VirtualBox, VMware Workstation, and VMware Player. Client-side virtualization can be used in several ways. For example, it is commonly used by application developers to test code. Suppose you're developing an application that needs to run on both Linux and Windows. Using a client-side virtualization solution, you could install Linux and Windows virtual machines to test your code and make sure that it works properly on both platforms. Client-side virtualization also works well for demonstrations or for developing training. Server-side virtualization works differently. Instead of installing virtualization software on an existing desktop system, server-side virtualization software is installed on a dedicated server system called a hypervisor. The desktops of the guest operating systems running on the hypervisor can be viewed from standard desktop systems using a network connection. Server-side virtualization has several advantages. It provides better performance because the hypervisor operating system is optimized specifically to run virtual machines, and most hypervisor implementations provide advanced features. For example, many provide a form of clustering that allows virtual machines to be distributed between many hypervisor systems. This provides load balancing and fault tolerance. Server-side virtualization also has several disadvantages. It requires dedicated high-end hardware that is much more expensive than standard desktop hardware, and the virtualization software tends to be more expensive. Although some free hypervisors are available that are basically pared down versions of the more expensive hypervisors. Both client-side and server-side virtualization solutions include networking support for virtual machines. This allows them to connect to a physical network and communicate with other network hosts and the internet. Most virtualization implementations provide several options for how virtual machines can connect to a network. In host-only mode, the virtual machine can only communicate with other virtual machines running on the same physical hosts by creating a virtual network switch that runs as software within the virtualization software itself. In this configuration, the virtual machines are isolated from the physical production network. Sometimes this is referred to as sandboxing. This can be useful in situations when you want to test new software or troubleshoot malware infections. In NAT mode, a virtual switch is used in the same manner as in host-only mode. However, the virtualization software also creates a virtual NAT router that connects the virtual internal network with the physical external network. This allows virtual hosts to connect to the external network, including the internet, while still providing a degree of separation between the virtual and physical networks. In bridged mode, the virtual machines connect directly to the physical network. In this configuration, they participate on the physical network as if they were real physical computer systems. No separation exists between physical and virtual networks. This is a useful configuration for deploying virtualized servers. Because virtual machines can be configured to connect to a physical network, you need to implement security measures on them, just as you would a physical computer system. For example, a host-based firewall should be installed and configured on each virtual machine. Anti-malware software should also be installed and regularly updated with the latest definitions. Operating system and application updates should be installed within the virtual machines as they're released. And you need to implement user account restrictions, permissions, and password protection within virtual machines, just as they are on physical computer systems. The virtual machine physical host also needs to be protected. Make sure you've installed a host-based or network firewall. If possible, you should implement anti-malware software. This is especially true for Windows-based virtualization hosts. It may not be possible or necessary on Linux-based virtualization hosts like ESX or ESXi. Make sure you install updates to the virtualization software as they become available, and control physical access to the virtualization host. If an attacker gains physical access to the host, he or she could simply connect an external storage device and copy all of the virtual machines on the host. You also need to implement user account restrictions, permissions, and password protection measures on the virtualization host to prevent unauthorized access to the virtual machines on the host. The hypervisor is a key component in any virtualization implementation. There are many different hypervisors that you can choose from. Let's review several of the commonly used hypervisors. The VMware organization produces several different types of hypervisors. One of the more commonly used VMware hypervisors is called VMware Workstation. As its name implies, it's really not designed for a server environment where production servers are virtualized. Instead, it's designed to be used on top of a standard Windows or Linux workstation. It is commonly used by application developers for testing code. For example, suppose you're developing an application that needs to run on both Linux and Windows. Using VMware Workstation, you could install Linux and Windows virtual machines to test your code to make sure that it works properly on both platforms. VMware Workstation also works well for demonstrations and developing training. VMware also produces the ESXi and ESX hypervisors. They're designed specifically for use in the data center. They're commonly used to host virtual servers that provide network services in a production environment. ESXi is a pared down free version of the hypervisor, whereas ESX is the full version. Oracle VirtualBox is a desktop hypervisor that functions a lot like VMware Workstation. One of the key benefits of VirtualBox is that it's based on open source software, so it's available on the internet for free. Microsoft provides a hypervisor called Hyper-V. It's available with all versions of Windows Server since Windows Server 2008. It works very well and it's quite flexible. The only drawback is the fact that it's designed to support Windows virtual machines. Installing virtual machines that run other operating systems like Linux can be difficult. Another open source hypervisor is called Xen. Many Linux distributions include the Xen package that can be installed to turn the system into a hypervisor. Xen is very powerful, but it's more difficult to configure and manage than other hypervisor platforms. In this lesson, we discussed virtualization. We reviewed how virtualization works. We discussed the benefits of virtualization. We reviewed the different types of virtualization. We discussed virtual networking and security measures that need to be employed on a virtualization implementation. Then we ended this lesson by discussing several commonly used hypervisors.
All right. Okay, and just to let you know, a couple of informational points about virtualization. VMware is not free and it's quite costly. I've used Workstation quite a lot. I'm using it on both of my laptops here, and I have several virtual machines. Microsoft Hyper-V, there's a pared-down version on your operating system. You just have to enable it, and that's one of the labs that we're going to go through. Oracle VirtualBox is completely free and open source. If you're interested in building a virtual environment, I would investigate VirtualBox because it's relatively user-friendly and it can be used quite well, but you have to essentially understand some of the premises that we're going to go over here in these labs. The one thing about the virtualization, I'll tell you right now, if you're running a system that has less than 8 gigs of RAM, then do not run a virtual environment because your memory will not support it. Windows 10 Home is fine. You must have at least, I would say at least a 500 gig drive, or 800 is probably more. 1 tera is probably the best as far as performance. And your processor should be a high-end i5 or above, if you want to go that route. So just some additional information. And when we run the labs, you'll see some of the usefulness. And eventually I'll show you some of the virtual machines that I'm running on my system here. I have like 6 or 7 of them. But here we go. Okay, we're now in 10.5 for virtualization. Our first lab is the enabling virtualization lab 10.5.5. So we're going to do all 3 of these. We're going to take a break, just to let you know, and then we're going to go into our packet tracer or networking portion of our fun together this evening. All right. Okay, so in this lab, we're the IT admin, our little corporation. The employee in Office 1 will use her computer to run a virtual machine. So you need to enable virtualization technology, which is VT, in the BIOS. It's pretty straightforward. You restart, enter the BIOS, and for most of us, it's just a delete key. We enable VT save changes and then restart to the computer to verify the changes you've made. And basically, and I'll give you a kind of a heads up, you'll see that Hyper-V will be available for viewing. All right, let's start. So as we see, the system's already up. So let's go through restart, window, power, restart. It power down. And then before it comes back up, we want to hit our delete key to head into the BIOS. All right, and in the selections, there is a virtualization support. Go ahead and expand that. Now, this is a little bit tricky. We are going to enable virtualization, the virtualization technology. There's a VT for direct IO and a trusted execution, but basically we just want to, for our purposes, we want to enable virtualization. So if you select the virtualization item, we essentially want to enable the Intel, and this is specific technology that's probably on your system now. It may have something different depending on your specific version of Windows. So go ahead, recheck that box, click apply, and then you exit. Yeah, the one thing about, oh, and I should have shown you this before, but in our little search, if you type in hyper, or just virtualization, let's see. Good question. It is not showing. All right. Well, basically, it's not going to give us the opportunity to check it. All that it wanted us to do is enable it, and if we score the lab, I mean, that simple process will provide a passing grade. And you'll see that on your operating systems or on your BIOS as well. And it's really just that straightforward to enable the virtualization technology. All right. Let's go into our second lab, and we're going to actually create a virtual machine. And basically, we've installed, actually, in the last lab, the Hyper-V was actually not installed. But even if you install it and you try to go to the Hyper-V, and it's just another Windows or Microsoft installation, most of your OSs will have it. You just have to find it. But if you Google Hyper-V, you can probably find an installation for your system if you're interested in creating virtual machines. So anyway, so we've installed Hyper-V on IT admin. We're experimenting with creating virtual machines. So this lab, we're going to create 2 machines, VM1 and VM2, and we're going to use the following specifications, specs for each machine, and they're listed there. So let's get started. All right, so once you install Hyper-V, you can search for it in your search. It is another application, so just type in Hyper, and it should take you to the Hyper-V manager. And this is a part of most most Windows systems. So this is another manager that you should be somewhat familiar with. Remember, the Hyper-V is essentially allocated as a server of sorts, and primarily if you want support for that application and you're admin, and you've already had that set up for you, remember, this is a server-side installation for the most part, even though, as I said before, there is a pared down, very, very pared down version of Hyper-V on most Windows systems that are client-side, like VMware or VirtualBox. All right, so we go to our system here, the system level, because this is where we're going to install the virtual machines, because it does give you a listing here. So the first thing we do is we right-click on your system level, as with any other creation scenario. You have several items here. We're not going to change any of these as far as the server. Remember, this is being fed from a server. We just want to hover over new. We want to create a new virtual machine. So right-click, I'll do this again, right-click, new virtual machine. And now it'll start the virtual machine wizard. So basically, please read the instructions. It will just help you to create a virtual machine. You can use virtual machines in place of physical computers, et cetera, et cetera. To create a virtual machine, do one of the following. Click finish. We're not going to click finish because that will not help you to set the parameters or specs that are indicated here. So let's click next. First, we get the name of our virtual machine, VM1. Okay. And virtual machine location, D, Hyper-V. That's pretty much the default. Store the virtual machine in a different location. No, that's our location, the Hyper-V. So we want to click next. And remember, if you make a mistake or you think you made a mistake, you can do previous. We'll take you back to the previous page. So next, we want this to be generation 1 or first generation. Supports 32-bit and 64-bit, which is usually the case in a server side using Hyper-V. Generation 2 is a little bit different. We're going to stick with generation 1 as our instructions. Indicate. Next. We want to configure our startup memory according to this. We want 1 gig, and which is 1024 binary. So 1024 megs and 1 gig. We do not use dynamic memory. And basically, dynamic memory will generally use a range of memory based on what the application is needed within the VM. So we don't want to check that box. All right, next. All right, we do want to create a network connection. Remember, a network connection will provide network connectivity for your VM based on what you select here. And essentially, we want external, which means that we're going to use whatever network is on the host, and we're actually going to communicate with the internet. So we want external. All right, so our virtual hard disk name, and usually this is the default. It's usually the name of your VM .vhdx, which is standard in a Hyper-V. All right, so next, and you see that right here. That's our name, that's our location, which matches our specs, but we want our virtual drive to be 50 gigs. So we can change that to 50 gigs, all right? And finally, the operating system will be installed later, which is usually the case. You build a VM first, and then you can install whatever operating system you need for that VM, which is our selection here. But you can install your OS here too, if you have any of these media for installation. But we're going to install it later. We're just going to build a VM. So you can click next here or finish, but I suggest clicking next, looking at the summary to make sure it matches what you need, and then finish. So you see that our VM now shows up in our virtual machine under our host, and right now it's off, so it's not running. All right. Any questions?
Nope, not so far.
Not so far. So our second VM should be as simple. I'm going to buzz right through this, so keep up. Right click, new, virtual machine. Next, it's going to be VM2. All right. And here, Hyper-V as before. Next, generation 1, yes. Next, we want 2 gigs or 2048 for our memory. We do want to use dynamic memory for this. Make sure you check that box there. And then next, this one we want an internal connection for our network, which means that we just want to communicate within the host. So it's usually, I do this a lot if I'm testing cybersecurity or things like that. So it will not communicate outside of the virtual environment. So internal. Next, that's the name VM2 VHDX. Yes. We want our hard drive to be 250 gigs. So we change that to 250. Next, we're installing our operating system later. We do have some parameters here, which I'll show you how to take care of those. So we go ahead and click next. This is our summary. It matches what we need, and finish. So we have an additional, whenever you use dynamic RAM, it's a good idea to set the range. And all that means that it will utilize this range of memory based on what's needed by the VM. So here, we want to right-click on the VM, okay? And we want to go into settings. Now in settings, there's a memory. You see that we have memory here. We have it set at 2 gigs. You want to click on there, it'll open up our configuration for our dynamic memory. This is only because we have dynamic memory, but we want to change the range. We don't want it to utilize all this memory. This is essentially from the host. So we want to change the range to 512 megs, and then our top end or our maximum of 4 gigs. Okay, then make sure apply and okay, and that's set. All right, there you go. We have our 2 VMs. We have all of our specs set. Let's go ahead and score that lab. Any questions? All good?
All good.
Yep.
Cool. All
This
right.
is Carol. I was working on, when I started the Hyper-V manager, I was trying to add it to the right when I kept on getting stuck on it. So I finally realized after doing it that I had to click on the admin.
Yes, because your IT admin, remember that's your host PC or host. Hyper-V is actually a server. Generally you can't really change that, but all right. Yep. Just discovery, Carol. Right, our last.
Probably like a 30-minute discovery.
Uh-oh. Oh, wait. All right. Well, that's good. That's the best way to learn. Those
Right.
30 discoveries are excellent learning opportunities.
Thanks.
Yeah. All right. Our final virtualization lab will cover creating virtual disks. Right. So in this lab, we've installed Hyper-V, which is generally how we're going to manage virtualization. You're experimenting with virtual hard disk, and basically you can add virtual hard disk on your drive without actually adding any physical drives, just like adding virtual machines. So in this lab, we're tasked to create 2 virtual hard disks on the D Hyper-V virtual hard disk directory. Name these disks test 1 and test 2, and then give these disks these following settings. All right. So let's go ahead and start the lab. So once again, go into the Hyper-V manager. This is where you will manage all of your virtualizations. And once again, we're on IT admin, right?
Mm.
Now, make sure you select that. You notice there's not really a section for virtual drives, and usually virtual drives won't show, or virtual, yes, will not show, but we can inspect the drives to make sure they're actually created. So once again, it is new, right-click new, and we're going to create a virtual hard disk. So select virtual hard disk, and this launches the new virtual hard disk wizard. And so it's a very similar process. Take a look at your specs. So next, our first disk will be VHD. Supports virtual hard disk up to, and basically it's usually size and operation ability that controls your selection here. But yeah, we're going to select VHD, and we want the disk type to be fixed. So next, fixed size, that's the default. We want to name it test 1. Next, test 1. We want to make sure our location is on Hyper-V virtual hard disk test 1. And the name is going to be test1.vhd, which stands for virtual hard disk. All right. And you can also browse on the Hyper-V if you need to. but it will generally default to the location of your Hyper-V manager. Next, we do want this to be 500 gigs, so let's change that 127 to 500 gigs.
Excuse me, Dwight.
Yep.
Yeah, James. About the RAM on the first one, the minimum RAM and the maximum RAM. Do I need to put this or just leave it like that on the first exercise?
Put what? What are you referring to?
Of the Hyper-V. I'm still on the other one.
We'll have to loop back to that.
Okay, thank you.
All right. All right. So we want to change this to 500 gigs, right? And we don't want to change any of these parameters here. Next, our summary. It's always a very good idea to go to the summary, make sure everything is what you want, and then finish. As you notice, we don't see anything here, and I'll show you how to view your virtual drives in a second. So let's go ahead and create the second one. Right-click New, hard disk. Next, this one we'd like to be VHDX. This format supports virtual disks up to 64 terabytes, and it's, yeah, you'll see because that's VHD extended. That's essentially what that stands for. This format was not supported in OSs earlier than 2012 on the server. So it's a very, very good thing if you can create a 64 terabyte hard drive, that gives you quite a bit of space. All right, so we want VHDX. Next, we want it to be dynamically expanding, and that's another very useful tool based on what you need as far as capacity. So, and generally, if you have VHDX, you do want it to be dynamically expanding. This type of disk provides better use of physical storage space as recommended for servers running applications that are not disk intensive. The virtual hard disk file that is created is small initially and changes as the data is added. And that's a good thing. It's, as far as performance, if that drive can change based on the amount of data, you know, it's always performing at its highest capacity. All right, next. So we want to rename this test2. And that's our location, Hyper-V, virtual hard disk, test2. Next. We want the size to be 4 terabytes, or that's 4,000 gigabytes, or specifically 4,096.
Hey, Dwight.
Yeah.
This is Danielle. The file name was supposed to be test2.vhdx.
No, you don't need to add the extensions.
Oh, okay. Okay.
Just put in test2 there. You'll see that it will add it automatically when we look at the summary. So do not add the extensions here. So we want to give it 4 terabyte drive or 4,000 gigs. And then next, and you see that in our summary, we have our correct name here because it will add that extension for you and it creates less confusion. And everything matches, and we finish. Now, if you want to check, usually you can edit the disk here, but I think that's disabled. You can actually click on inspect disk. It'll actually show you where our disks are in the Hyper-V. So we have test 1 and test 2, and you can double click on these to open them up, take a look at their parameters, just to make sure that they're there. That's the best way to check, because they will not show on anywhere else in your Hyper-V manager. Although you should see them in File Explorer. As you see, if you open up your Hyper-V, I'm just in File Explorer. And because it's virtual disk, it's not going to show you the actual disk drive. That's a little bit Yeah, the best place to check for virtual disk is in the Hyper-V manager. And there's other ways to check it in the manager, but most of the other ways are disabled for our lab purposes. Any other questions? Are we all good? Let's go our lab.
Yep, all good.
We're good? Good job. All right. So I have 7:04. Now, James, if you want to stick around and review, you can do that during the break. But let's take a 26-minute break. When we come back, I'm going to show you a video on cloud services just to give you an overview, because you will see that on the PC Pro somewhat, on the Network Pro definitely, on both of the CompTIA certs definitely. So I'm going to show that, and then we're going to go into our packet tracer portion of our excursion or experiment or learning. All right. So let's be back at 7:30, and then we'll move on. All right.
Sounds good.
Okay, great. See you all shortly. All right, so before we launch into our packet tracer adventure, and I will guarantee you'll have a lot of fun. And no one's really smiling, everyone's grimacing. We'll learn a little bit more, and I promise I won't bore you too much. But I do want to share with you a cloud computing overview. We don't really have a lab in cloud computing. Hey, Jackie, who's your friend back there?
Oh, that's Fiona.
Who is that again?
Fiona.
Oh, Fiona.
She's my Dalmatian.
Yeah, spotted and everything.
Where's your at?
Yeah, I always tell people that yes, she does exist, because I was like, oh, I only see him on the movie. I'm like, no, she's real.
All right. Well, hello, Fiona. All right. Let's see, everyone's back. Okay, let's view a cloud computing overview and make sure your packet tracers are ready to go, and we'll move on from there. All right. Okay, just had to let someone back in. All right. Okay, here we go.
Let's spend a few minutes talking about cloud computing. In this lesson, we're going to provide a generic overview of what cloud computing is and some of the forms it takes. The cloud is a set of hardware, networks, storage devices, services, and interfaces that enable the delivery of computing as a service. The cloud part of cloud computing means that a cloud service provides everything you need to perform some computing tasks. Whether you need CPU cycles, a complete computing infrastructure, applications, defined business processes, or collaboration solutions. And one of the biggest benefits is that you have access to these services wherever and whenever you want. Let's take a look at how it works. The term cloud means that you're receiving these services from a location that is not local. The cloud you see here is composed of things like computing hardware and networks. It includes storage devices and a network controller which communicates with these devices to gather the information about the network. It includes services like applications and interfaces that allow you to connect to these services using the network and a local device. Cloud services include the delivery of software. In other words, you can run an application from the cloud. It provides infrastructure for an entire computing system if needed. It may provide storage that you can use. The key thing to remember is that the cloud is separate from the local devices. This is a powerful concept. In the past, let's say we needed to run a word processing application. We needed to use that to complete our day-to-day work. Well, how did we do that? We installed the application on our desktop system at work, and we did whatever it is we needed to do. But what happens if we went home for the night, got a call, and someone said, "I've got to have this report done by midnight tonight or you're out of a job. Fix it, buddy." Well, what did you have to do then? You had to go back to work to use the computer. Or you had to use some kind of VPN connection to get back into your computer. Why? Because that's where the application you needed to do your work was installed. Your only other option was to install a second copy locally at home. That's really inefficient because most of the time you're going to use the copy at work, and very rarely will you use the copy at home. So you paid for two pieces of software. One you will only use on rare occasions unless you are dishonest and installed the same copy twice, which you shouldn't do because it's against the law. Likewise, if you were in the office one day and just decided, you know what, I'm sick of being in my cubicle. I want to go outside and get some sunshine. So you take your notebook or your tablet or your smartphone with you outside and you think, I'm going to work on that report out here in the sunshine at the park instead of being in my office. Could you do that? Well, you could if you once again installed that application locally on each of those devices. And if you had a workstation at work, a notebook system that you traveled with, a tablet system that you use just for fun, and a smartphone system. Then you would actually have 4 different copies of that same application to use all of these different devices to do your daily work. Well, with cloud computing, we take away this whole concept of locally installed applications. But there's more to it than just applications. When you use the cloud, you use a network connection, and you connect to either a public cloud on the internet or a private cloud provided by an organization, and then run the application out of the cloud. In other words, the application runs on hardware provided in the data center instead of over here on the local devices. And this is nice because I can run that application from the desktop to my computer at work. And when I go home and I get that call at night and they say, "We've got a problem and you need to get this report done immediately," I can just use my laptop at home or maybe my home computer and connect to the cloud, run the very same application, and access the same data because the data is being stored in the cloud now, not on my local hard drive. And then if I'm having one of those spring fever days and I want to go to work at the park instead of in my office, I can sit out with my tablet and once again, I can access the application from the cloud. I can work on the very same data that I was working on for my desktop system at work and accomplish the same thing without having to install that application or copy the data I'm using on each of these different devices. Now, as I said a minute ago, cloud computing comes in different forms. We have public clouds that can be accessed by anybody. We have private clouds that are provided by a particular organization, and access is restricted to just that organization or to other paying clients who want to use it. And we have hybrid clouds, which kind of combine the best of both worlds, public and private. Cloud services include the delivery of software, infrastructure, storage, or a combination of all three in a complete package over a network connection. And that network connection could be within your organization on a LAN, or it could be an internet connection to a cloud that's available on the internet. From the user standpoint, the great thing about the cloud is its flexibility. The fact that you can use whatever device you want from wherever you're at and have access to the resources you need without having to install and set everything up manually. Clouds are also very attractive to management and to business owners because clouds are elastic in nature. And this is very key. Basically, users can request resources on demand and then just as easily deprovision those resources when they're done with whatever they needed them for. Let's take a look at some of the other benefits and features cloud computing offers. The first is self-service provisioning. Self-service provisioning means that your users can easily get cloud services without having to go through a lengthy approval process. Basically, your users just request the computing power, the storage space, the applications, or whatever it is they need from the cloud service provider. And within a matter of seconds or minutes, they have those resources. In addition, clouds also provide APIs, which basically provide a means for resources stored locally to communicate with services provided by the cloud. For example, you may run an application out of the cloud that needs to update a database that's stored in your organization. With APIs, you can do that. Clouds also provide metering because it's kind of a pay-as-you-go type of system. The cloud provider has to decide how they're going to bill for the service. It's not like the old system where we purchase the hardware and we purchase the software and then use it. You pay for what you use, and so they provide a tracking system to bill you for what you have used. One of the key things that makes cloud computing so beneficial, aside from the self-service provisioning, is the fact that cloud applications are designed to be easy to use. This is very important. Your end user should not be intimidated by the concept of using a cloud resource. The infrastructure underneath cloud computing may be really complex, but the end user interface, generally speaking, is relatively simple. So the user says, well, I can just open up that application in my browser and do what I need to do. And they don't have to worry about anything else. With this in mind, now we need to discuss the cloud service delivery models that are currently in use. There are 3 of them you need to be familiar with: infrastructure as a service, platform as a service, and software as a service. Let's begin by taking a look at infrastructure as a service, or IaaS. IaaS is the delivery of what we traditionally associate with computer hardware as a service. It provides storage as a service, as well as computing resources as a service. Essentially, you can rent storage space in the cloud instead of having to go out and buy a whole bunch of hard drives that you install and use locally. Likewise, you can use computing power from the cloud instead of having to go out and buy new high-end systems to do a particular job. You simply rent time from an IaaS cloud service provider. That way, you don't have to go out and buy that hardware. This saves a lot of upfront money on purchasing hardware, and it also provides the flexibility, scalability, and elasticity that we talked about earlier. If you end up with a project that requires a lot of storage and a lot of computing power for a limited amount of time, you scale up. And when you're done with that project and you don't need that computing time anymore, you scale back down, so you only pay for what you need. Platform as a service, or PaaS, offers a complete development environment. Basically, it's an environment that you can use to create cloud-ready business applications. The cloud service provider delivers an entire solution stack. This solution stack is an integrated set of software that provides the developer with everything they need to build an application. And this is really kind of an outgrowth of the traditional concept of web hosting. If you've used a web hosting provider in the past, you know that most of them provide you with some kind of web development interface that you can use through a web browser to build your web page. This is the same type of thing, just on steroids. Instead of just being able to build websites, it provides you with a complete development environment to develop entire integrated suites of applications. And once again, the primary benefit of doing it this way is the fact that your development and deployment activities take place entirely in the cloud. So you don't have to manage or maintain local systems because it's all done for you by the cloud service provider. Some cloud service providers will provide you with development process features like software design, software development, testing, and deployment. Just as with infrastructure as a service, platform as a service provides you with the flexibility and the elasticity you need to scale up when you need resources and to scale back when you're done. Software as a service, or SaaS, is really designed more for your average end user. SaaS provides end users with business applications that they need to do their day-to-day work. Instead of installing the application locally on their hard drive, they simply open a web browser and go to their cloud service provider. And within that browser, they run whatever application they need to use: word processor, PowerPoint, spreadsheet, whatever it is they need to do. This was one of the first implementations of cloud computing. And as I mentioned earlier, without cloud computing, if your organization hires 20 new people, and all of those 20 people need to use a word processing application, meaning the application on each of those users' computers, you had to purchase a copy and install it. Whether or not the application is used all the time, part of the time, or never, you still had to buy the software. That's the advantage of SaaS. You only pay for what you need. If the employee uses a word processing application 8 or 9 hours a day, you pay for it. If the employee uses it 3 hours a month, that's all you pay for. One of the key advantages of SaaS is that you can try new software without committing to it. Try out an application on a rental basis, pay for the time you use it. And if you really like it, you can go ahead and use it more. If you don't have to spend any money on it. Before we finish, there's one other thing you need to understand about SaaS. SaaS comes in two forms: simple multi-tenancy and fine-grained tenancy. With simple multi-tenancy, each customer of the cloud service provider has their own resources that are completely segregated from other customers. And you can do this, but it's a relatively inefficient way to do things. Fine-grained multi-tenancy is more efficient. It offers the same level of segregation as simple multi-tenancy, but all of the resources that are used by each customer are shared. Your data is segregated, so nobody else can see it, but your computing power and applications are shared. With simple multi-tenancy, you essentially say, I want to purchase this chunk of resources, and whether I'm using them or not, no other cloud customer can use them. Basically share and pool the resources so that nobody hogs them. You can also use a Windows To Go installation, which is available in Windows 8 and later. Windows To Go allows you to install the Windows operating system on a USB flash drive. To boot the system, you plug the USB drive into a USB port and configure it to boot from an external USB drive. When you do, the Windows operating system is loaded from the USB device instead of an internal hard disk drive. And that's it for this lesson. In this lesson, we talked about how cloud computing works, we defined cloud computing, and we looked at three different types of cloud computing: infrastructure as a service, platform as a service, and software as a service.
All right. I just wanted to add a little bit to that. Not too much, just a little bit. Just to let you know, cloud computing is very, very new. Essentially, it's been stable now for probably just 2 to 3 years. So that's how new it is. There's 3 high-end vendors that are controlling the cloud computing services that you may or may not know. That's Amazon or AWS. That's Microsoft with its Azure, and Google with its Google Cloud. They're controlling about 99% of the cloud services out there enterprise-wide. So just keep that in mind. You may see that on your certs. Also, there's several as a service now, in addition to the 3 that he talked about. The one that I would want you to be cognizant of is database as a service. This is very, very new, with the idea of data-driven decision-making and all of that. A lot of these data that are introduced now are being hosted on a cloud and delivered as a service. But there's several as a services out there now. So I just wanted to add that. All right. So we will talk about cloud services a little bit more. Just keep that in mind. So make sure you have your packet tracer open. I'm going to go right into this. We'll probably spend another 45 minutes building our fourth iteration of our packet tracer environment. So I'm going to go ahead and share that.
When we go into packet tracer, do I go under introduction to packet tracer chapter 4?
Are you talking about the actual application, or what are you referring to?
On the Cisco packet tracer, like how do you get into the 4th module?
Well, are you talking about the course, right? Or
Yeah, on the course.
now you don't have to take the course. Essentially, that's useful, and I would recommend it. But you should download the application, packet tracer.
Okay.
That's what we're using. So once you download the packet tracer application, it'll look like this. It'll be a blank environment, not with all these components. But that's That's what we're using for our exercise.
So once I download it, it'll look like that?
Yes.
Okay. Okay. I
So
just
if
want to
you-
make sure I was at the right one.
Yes, and once you log into the Cisco Academy, scroll down to the bottom and you'll see the appropriate download links.
Okay. Thank you.
Yep. Okay, for everyone else, this is going to be our fourth, I'll make it larger. So as you notice, this is our third iteration with a few changes. What we're going to go through tonight, we're going to configure our telephony. We're going to configure network phones. And once we're done, and this is what you need to have, basically your network phone has to have an IP address and a phone number. And basically when you go into the phone and go into the GUI, you can actually communicate phone to phone.
We can't see the whole screen.
Okay, I'll open it up in a second.
Okay.
All right. I always forget about that. All right. So once you've completed our configuration here, and I'll talk about this, don't worry about the main router. We'll talk about that later. But I will just have you add a firewall and also add a serial. That little jagged line represents a serial connection. But on the phones, our primary purpose this evening is to configure this little environment here where we have a telephony router. We're going to call it another switch and then 2 IP phones. And when you go into the phone, you'll actually be able to communicate. You just click on the receiver on the handset and you should hear a dial tone. Let me see if I can. Why not? Actually, if it's configured correctly, once you lift the receiver, you will hear a dial tone and you can dial the number of the other phone. This is phone number, first IP phone, and the number here is 54002. Excuse me. And if you click on the second phone, the phone number is 54001. So we can actually dial that one, and it's actually ringing. So if you go to the second phone, you see that it's ringing with the flashing light and we're connected. So that's what we're going to end up with on our scenarios here. We're configuring these phones. So that's a lot of fun, right? All right. So quickly, before we start configuring the phones, I would like for you to, now this particular device, and we're not going to configure these at all, we're just going to add them into our environment for our fourth packet tracer. We will work on them eventually. This is a firewall, and it's an ASA in your devices. If you go into your in devices, at the very bottom, you have a list of security devices. And if you click on the security devices, it'll bring up the ASAs, essentially firewalls. And you have a 5505, 5506, they're essentially the same. I'll just choose a 5505. Let me make this bigger. And just call it first firewall. You don't have to assign an IP address or anything like that. And then just connect it a straight through cable from the firewall to your router. Now, you may say, well, wait a minute, I only have, well, you should have more connections on this router. So let's take a look at that. Remember, we added 4 Ethernet connections and 2 serial connections. So you should have those on your router, right? And we only configured what we call our main routing line, which is the fast Ethernet 00, or you could, depending on, you could have either the 1911 or 1811. Both will support additional ports. So what I want you to do is just add your cable, and I'll do it again here, on the firewall. Go ahead and add your straight through cable, and that's the silent line. Just choose one of the ports. It doesn't matter right now. Just choose the port and connect it to one of your open ports on your router. And as long as you have green lights, that's fine. As I said, we're not going to do anything about configuring this yet, but yeah, the whole purpose here is to make sure that everything is going to go green. One second. Okay, sorry. So go ahead and connect that, make sure everything goes green. And what I'm going to have you do now, and there's going to be a reason for it later, we're going to take that straight through cable that we have going to our cloud PT or internet. We're going to change it to a serial cable, and that's the jagged, or, you know, essentially think of this as an S to stand for serial, and that's this cable here. And so you should have 2 serial ports on your router. So let me go ahead and delete that and reconnect it. So all you need to do is click on the solid jagged line, click on one of your serial ports, and one of the serial ports on the cloud. And once again, we're not going to configure that at all. I just want you to make that change. There's going to be a reason for that as we move forward into networking. Any questions about that?
So delete the dashed line.
Yeah, delete that's a crossover, crossover Ethernet, and we're just going to add a serial line. So yeah, we don't want 2 there. We just want the one serial line here. Okay. All right. Before I get to the naming, let's go ahead and work on our telephony configuration. So what I need for you to do down at the bottom, we want to add a 2811 router. You go into your network devices. It's here, and I'm going to start this all. I'm going to delete all this and start over so we can all do it together. And you're like, oh no, Paul doesn't know what he's doing. All right, so 2811 is, and mine is the last router. Add that to your working area. We're going to add all the devices, and then we're going to, well, we'll do them one at a time. We're going to label this telephony router. And its IP address is going to be 192.168.10.1. Okay. That's one. Yeah, let me delete the square because we're going to do that a bit as well because it keeps asking me to label it. All right, 192.168.10.1. That's our telephony router. Get this to this table.
You said 10?
10, 10. 192.168.10.1.
Thank you.
Okay, and then go ahead and add a 2960 switch, which is our favorite switch. And this is our telephony switch. It's used for network phones. And you'll still see businesses that are using what's known as voice over IP or VoIP. We use them at university, at both ASU and GCU still. It's kind of outdated technology, but it's still appropriate even though everyone has cell phones. It's still used somewhat. All right, then go to end devices. And if you see in there, there's a phone. We want to grab 2 of them. Oh, not an analog. We want a digital or IP phone. So do not grab the analog. That one will not work. That's just a regular RJ11. So we want to grab the IP phone. And it says IP on there. And go ahead and grab 2 of them. And we're basically, let's go ahead and label these following our naming convention. First IP phone and second IP phone. Oops. Just to follow our designated naming convention. All right. With IP phones, they do need power. So you do have to click on them. And here in the bottom right, there's a power adapter. You have to actually, and you should all have some idea. You just need to plug it into the phone. And as you see, there's a little port right there underneath all of the cables. And we just want to plug that in. And that basically turns the phone on. And you have a display on your GUI.
Wait.
So go ahead and do that for both phones. Just left click, grab, and plug it in. All right. So now you should have 4 new devices.
Dwight, can you tell me where you plugged it in on the back of the phone? Was it just a little?
It's just a little port. You go into physical. See?
Right.
Right there below that RG11 adapter port. You see it? You should be able, it's really the only place that it'll stay on the phone. Get it bigger.
And then how do you know if it's on?
Well, if you go to the GUI, it'll just say configuring VLAN. The display will be active.
Okay, thank you.
That means it's on. All right. Okay, so the one thing that you've noticed on these phones in the config, there's really no way to add any settings. It's all slave to what's known as DHCP. And if you remember way back, DHCP is a way to issue IP address, and eventually we will have DHCP services running throughout our network. But for now, we need to actually configure our router to perform DHCP services. All right. And the way we're going to do this is something that will become very handy, because we need to do a configuration on both the router and the switch. All right. So click on this new router 2811. We're not going to add any additional ports to it. This is serving just its purpose is just for telephony. So we want to go into the config, and specifically, we want to go into the CLI. The CLI is your command line interface. It's the only way that you can configure a switch. The routers are a little bit more user-friendly and they have GUIs to them, but you will need to understand the whole command line interface and how useful it is. It will become basically how you're going to configure your networking devices. As a matter of fact, before the updates, before Cisco went into a lot of updates, it was the only way to configure these devices. Okay, 1 second. All right, so first thing you want to do, as it states there, press return to get started or press enter. That will take you to a prompt that shows the router. And now there's two very basic commands to get into the point where you're going to configure the router. The first command is enable. That enables configuration.
I'm sorry, it's Carol. How did you get into the actual return?
Enter.
Or some?
Yes, hit enter.
Oh, okay. Got it. Sorry.
So type in enable and enter. You get the little pound sign, and that means that you're now you're in the protected or administrator mode of the router. And we'll talk about logins and all that, but all of these routers in Packet Tracer, you can go into the admin mode without any special logins. And to get into the configuration mode, oh, and just to let you know, there's a shortcut for this. Generally, with Cisco, you can use the first 3 letters, and that will, the programming, the software, the firmware will recognize. The next command is configure terminal, which you don't have to type all that out. So get used to typing in conf T, and you'll hear that a lot. And that stands for configure terminal. And that will take you into the configuration prompt for your device, for your Cisco device. Other networking devices are similar, but these are all specifically allocated for Cisco. Okay, so just to review quickly, enable or ENA and CompT. Now, what we want to do is we want to configure that we're going to configure the fast Ethernet port, and let me just minimize this. We want to configure the fast Ethernet port because that's what we're going to connect to the switch, and then ultimately connect to the phones. So to do that in command line, you have to call that port or that interface. That's what it's referred to in networking language. So type in interface, and then the port name itself is fast Ethernet. I can't type. And it has a numeric allocation 0/0. And just to review, I got that right from the router right here. That's exactly how it's allocated. So you want to type that in exactly. So interface fast Ethernet 0/0. And you can also type in int. I think int F00 still works as a shortcut. Let me just, we're all about shortcuts, so let's see. And yes, the delete key will not work in the command line interface because this is all old school technology. So it's an arrow key and the backspace. Yeah, we'll try that later. So just type in that and click enter, and it should show you that you're now in the configuration of that port or that interface. It should display config IF. So we are configuring that particular interface. Now, as opposed to,
Dwight, it's James. What were the phone again? Are the analog or are those
Pardon?
analog? Are those the analog or the IP phone?
Oh, those are IP phones.
Oh, okay.
All right. So normally we would go in and configure our settings using the settings. We're going to do the configuration right on our command line interface. So we want to add our IP address. So just type in IP address and a space, IP space address, and then our address that we allocated for our router, 192.168.10.1, right? A space, and now we actually have to add the subnet mask in manually, 255.255.255.0. So that's going to be the IP address of, and so I'm going to go back and forth a little bit. So if you hover over the router, you see we don't have an IP address set, but we're going to set that now. So once you've typed all that in, hit enter, and if everything is correct, you won't get an error. It'll just go on to a blank prompt. That means that we've now configured that IP address. And if you hover over that port, you see that it now has an IP address, 192.168.10.1. Now the port is still down. Now normally you would go into the GUI and click the checkbox, but we're going to do command line. So the command to bring the port up is no shut, which means no shutdown, which is, there's an explanation for that in the old Cisco days, but all it does is make sure that the port stays up. And if you've done that correctly, you'll see that the link 5 change interface fast Ethernet 00 change state to up. And if you go back to your router, you'll see that that port is now up.
Can I ask you about the configuration line again? Because I didn't get that to come back right.
What happened now, Carol? So you typed in enable CompT to get to your configuration.
Correct.
And then you typed in interface fast Ethernet 00, right?
Right.
And that should give you the config IF, which essentially means you're on that port, right?
Mm-hmm.
And then you type in the IP address. So where are you having a problem?
When is there a space between it 192.168.10.1?
No. There's a space between this address and your subnet mask only.
It is, okay.
Yeah, there's a space there. I can highlight it. Space.
What was the command line to initiate the system configuration dialog?
Where are you? The very beginning? Ask that again, Angel.
The no shut, is that what you're talking about?
Yes, just the first command line to enter the system configuration dialog onto the router. What was the
You
line?
just hit enter. It should show you this. Press return to get started. And that should take you to the router prompt.
Okay, yeah, it's not showing up on mine.
Make sure you're on the CLI, right?
Yes, you have to be on the command line interface. Here, I'll do this all again. All right. So click on your router. You may be on the config.
Right.
This is not active. This is just showing you all the commands. This is a display. You have to be on the CLI tab. Now, when you're on the CLI tab initially, now I'll start this. I'll reboot the router. This is the best way.
Sure.
This one, here's the power button. Turn it on. And you notice that it's now rebooting. So if you get this prompt, would you like to enter the initial configuration dialogues? Select yes, or type in yes.
When I did yes, it did something weird. So I did no, and then it got me to where I needed to be.
Okay. Okay. All right. For our purposes, thank you, Stacy. Just enter no, and it should get you to this press return to get started into the configuration dialog. And mine is acting weird.
You're on config.
There you go.
Oh, there.
Yeah, so make sure you're not on config. Make sure you are on the CLI. And then that will give you the router prompt. And then from there, you type in enable.
It's not
And then
showing differently.
that will take you to your configuration administrative area. And then we access that port interface. Let me see, I think the shortcuts still work. Yeah, you can type in int and F0/0 / and that will take you to that interface.
That's giving me an error.
What is?
When I put in int F0 / 0, and then it says invalid interface type and number.
You have to make sure you're on the root config. Are you in config IF?
Yes. Well, no, not on that one. Like, it's exactly like yours. So it says router config, and then the #, and then I put an int F0 - 0 or /0, enter, and then it says invalid interface.
And you put a space in between int and, well, it's really hard to go ahead and share your screen. Okay, close this. Let's take a look at your router. You may not have a hover over your, yeah, you're. So you have gigabit ports.
Oh, so I need to change those out. Sorry.
So you added a 2911. That's add a 2811, so you can be like everyone
20.
else.
Okay, it's probably couldn't read it with my glasses.
Yeah. And you'll have the fast Ethernet ports.
Okay, thank you.
Let's all use a 2811.
Okay.
All right. Okay.
What's this one?
Let's just get back into it. So I'm not going to reconfigure this, or, well, maybe I should. So at this point, you want to make sure you type in your IP address for your interface, or for that port, for your router, which is 10.0, and you have to add the subnet mask. And then you hit enter, and then you type in no shut. And since I've already configured mine, oh, no, I didn't save it. So I need to reconfigure. So interface 192.168.10.1, and then the subnet mask. What did I do? Oh.
Do we save it with the Control Z?
Well, I'll show you how to, yeah, that's one way, but let me make sure. Let's see. Oh, you don't need interface here, you need IP address. Duh. So this is IP address. So yes, that's right. Can't use delete, just use the back arrow and the delete, and the backspace, IP address, and then all of that information, and then enter, and then no shut brings the port up. Now from here, those of us that aren't aware of Control Z yet, you can just exit, 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 and basically, in all the Cisco devices, there's an auto save feature. Typing in the chat. Okay, I won't type. Make sure you're in the CLI, James. If you're in the config, you can't type.
What helps, James, is if you put the two screens right next to each other, Dwight's command screen and then your command screen, just match them up right next to each other, and then just match up every command after the pound sign. After the pound sign, make sure that the command on your screen is the same on the white screen.
That's a good idea.
They should all match up after the pound sign.
So if you exit all the way out to the router, that's the autosave. The other way is Control Z. We'll learn more about that as we get into more in-depth configuration. So basically, we should have that router configured with our IP address of 192.168.10.1, and the port should be up. All right, so that's the first part of what we need to do here. And now let's move ahead. We're going to begin the configuration to support the IP phones. So we are going to actually enable DHCP on the router. So go back into our command line interface. And let's go back into configuration mode. Remember, enable. The chats are coming in. You have to click sometimes in the box. Yes. All right. So the process is enable, CompT. That takes you to configuration. And now we are going to configure DHCP. So the command is IP DHCP. And we want to support voice. This is VoIP. And we want to create a pool of addresses, which is what we're stating here. So pool and then voice. Spelled correctly. IP DHCP pool voice. And that's going to offer a pool of addresses for voice only. And we can do this and still have it connected to our regular network. So enter, and it goes into DHCP config. You should see that on the indication. So now we want to provide a starting place for our pool of addresses. And generally, it will only issue obviously, the addresses in the pool. So to configure your IP pool, we want to, let's see, what is it, network. And then your starting IP address, network 192.168.10.0. And basically this is stating that what the router will do, it creates a routing table of IPs, and it will obviously skip over 1 and then begin at 2 and begin to issue IP addresses with that configuration. in the command line, whenever you're dealing with IP addresses, you always have to include your subnet mask. And for Class C, and we'll talk about this.
Dwight,
Yes.
after network, the IP address, you're talking about the IP address of the telephoning router?
No, we're talking about, we're creating a pool addresses for the phones.
Okay. All right.
Okay.
Because we don't have the 0, right? The 10-0?
Yeah.
Yeah.
That's what I was saying.
Yeah, don't worry about that. We're just creating we're creating the network using DHCP, so you're not issuing a .0. That's reserved anyway.
Okay, I got it.
You're
That's
not
what I was.
issuing a .1 because that's already allocated. You'll start at .2. So that's all. You're setting that up. It's already, the protocol knows that basically what address to start with in this configuration. But you always start with .0 because it needs to know what range of IP addresses are in this network.
Oh, okay. Yeah.
So just go ahead and hit enter. So now the pool of network addresses are available. You need to continue the configuration and identify the default. So this is where you create an exception. You're going to identify the default router, and the syntax is default dash router, and then the IP address of the router.
Is that a space between the dash and the router?
No, default dash router, no space. And then the IP address of the router, and then enter. Believe me, if you have anything typed wrong, the system will tell you. And as you see in here, it does give you the indication of Control Z. That's the quicker way to save everything in case you get mixed up. And we also have an option prompt that we have to enable, and this is for IP phones. This is required. If you don't do this option, then the system will not know that you're issuing IP addresses to IP phones, and you're issuing them from the default router. So you put in the IP address of your default router again. So it's option 150, and it's just one of the required option for VoIP. So option 150, IP 192.168.10.1, enter. So now our router is ready to begin issuing IP addresses to our phones. So let's go ahead and Control Z out of here. Basically, you get the same indication if you exit out, configure from console to console, which means it just basically save. So I would just go ahead and exit out of the administration mode completely. Close down your configuration. Make sure you have everything in there still, at least your IP. So everything is saved. We're all good. IPv4. All right. So let's go ahead and connect everything. And before we continue our configuration, because actually the issuing process will take a little bit. So go ahead and do straight through cables. Go from that port that we configured, right, to the switch. I'm just going to go to the gigabit port. It doesn't really matter. You can choose any port, and then go ahead and connect your IP phone. You have to select this switch. We're connecting this directly to a switch, and connect that to one of the. I'm just going to use Fast Ethernet 1, and also with the second phone, I'm just going to use Fast Ethernet 2. All right. So these are just straight through cables from the phone to the switch and from the router to the switch. Make sure you use that Fast Ethernet 00. All right. Okay, so now we have the router configured.
Can I ask you a question?
Go ahead.
When you click on the phone, is it a switch that you connect to?
Yes, I did say that. Yes. Select
Oh, okay.
switch. Switch to switch. Phone to,
Switch.
yes. Switch
Okay.
connector to switch.
Thank you.
Yeah. All right, so we got the DHCP configured, but now we need to configure the router to recognize the information coming from the phone as network information. So let's go back into the router, back into the CLI, back into configuration mode. So hit enter, enable, CompT, all right? And so now we're going to enable the telephony service. So that's what we type in, telephony service. And that should take you to the config telephony prompt. All right. So now we're going to essentially set the number of phones and the numbers. Basically, we can. Let me show you this before I continue. So on the phones, they have these as with most phones, you have these memory. You have the dial and you have memory buttons here, or fast dial buttons. We're going to set these. There's 6 of them, so that they basically we're going to make sure that those can be enabled for fast dial. And generally, you do this with this configuration. Right. So the first thing you want to do is configure the max amount of numbers and phones, phone numbers and phones. So the syntax is max dot dn designated numbers space 5. We're just going to say 5, but you can indicate as many phones. I think it's up to on one router. It's a large number, but we're just going to indicate 5 and hit enter. So it's max dash dn space and 5. And we're also going to indicate the amount of phones, and these are called e-phones. So max dot e-phones space 5 as well. So we can have up to 5 phones, and each phone will have a phone designated number, which generally is what the phone company will do. All right, so we need to tell it within telephony where are they going to get their connection from. Basically, where are these phone numbers going to be issued? So essentially, that's our telephony router. So where they're going to get their IP addresses from. So IP source space IP space source, and this is source dash address. So it's IP space source dash address, and then we enter the IP address of our router, our telephony router. So that's where the addresses will be issued from. And then we have to designate a port, but there's a specific port on this 2911 or 2811, which router are we using? 2811, that we have to designate it as our issuing port. So that's IP space source dash address space the address of the router space port space 2000, and enter. And now we're going to assign those buttons. So auto.
Quiet real quick.
Go ahead.
This is Danielle. For some reason, I keep pushing enter. Like I don't know how to get it out of the last one. I exit and I press enter, and it just does the router. It says router and the hashtag thing.
Okay.
So I don't know how to, like, it's not clearing out or anything so that I can start doing that.
Okay, share your screen.
Okay. Hold on.
It sounds like you already exited out and then never restarted.
Yep.
New command.
Or you're pressing the wrong key.
Can you see it?
Yep.
Okay. Because
From here, you want to type in config or conf t.
it's because this whole thing is from like the last one, and it's not letting me like go out of it to do the next one.
You're at the router administration mode. You just need to type in conf t there. CONF space F space T. Enter. There you go.
Okay, like that?
Yeah.
Okay.
So that takes you into configuration mode.
Okay.
Okay?
Thank you.
Yep. All right. So then you have all this to type in.
Okay.
Yeah, you want to go into telephony service and begin to type in all of Mac's numbers, designated numbers, Mac's phone, the source of the IP addresses from the router. And then we're going to designate these automatic dial buttons, so auto assign, auto space assign. Then we'll start 4 to 6, 4, 5, and 6. So 4 to 6, enter, and then you do the same 1 to 5. And this sequence is kind of odd, but it's just the way that it works to assign those buttons. So auto assign 4 to 6, auto assign 1 to 5, and enter. So now our router is all ready. You Control Z, get out of there. You can even exit all the way out to the base of the router. So that's all we need to do for the router. All right.
I guess it's Carol. I missed that last config command.
Which one?
The very last one. I did the, yeah. The numbers. Auto assign, okay.
Auto assign 4 to 6, auto assign 1 to 5. And it has to be that sequence. It's just a nuance.
I never left the, what was that?
And then I just exited out. Got it?
4 to 6 and 1 to 5, okay.
Yes.
I just
Thank you.
router config telephony, that's it.
What's that, Jay? After you config telephony, you have to.
You only have to router config telephony, and then that's it. Router config telephony, and then I cannot put the 5 max.
Okay, we'll come back to that. I want to try and get through this.
Okay.
Okay.
Is it always recommended to command line prompt exit?
No. Well, to configure telephony, you have to use command line interface.
No, but I mean to actually type in exit.
Oh no, you don't have to. It's just I normally do that because that's how if you exit out of all the config and the routers and the switches have an auto save, or you can just do Control Z and then just exit. I don't like to leave it in configuration mode or administrator mode. That's just a security thing. Because
okay, so that's just a good habit then.
It's a good habit. If you have the hashtag, you're now in admin mode. You can actually do some things. So I always exit out to make sure I'm at the core of the router. All right, so let's move on to the switch. We do have to do a couple things to the switch to make sure it supports our DHCP. So launch your switch and go into the CLI as well. And yes, it's Cisco, so the same process to getting configuration applies here. So enable conf t. All right. And what we're going to do here, and we are going to talk about this in detail, but we're going to basically configure the VLAN 1 to be our voice VLAN. And in case you were paying attention on the video, VLAN is virtual local area network. It kind of follows the virtualization, but it's a little bit different, and we'll talk about it more. So what we want to do on our switch is we want to impact a range of ports or a range of interface. And you can do that on here instead of just typing in one port or one interface at a time. You can type in interface range, okay, 2 words, interface space range, and then type in the ports that we would like to affect. So we'll use a shortcut. And you know that all the ports on a switch, well, the ports that we want to impact are the fast Ethernet ports. So that's why I'm using F0. And then we want to go 1 through 5. Because I had connected the phones to ports 1 and 2. So I'm going to configure these 5 ports for voice ports. So interface range 1 through 5. And you see that the switch goes into config IF range. So you're configuring all of these ports all at once. And now, and once again, once we get into networking, you'll understand this particular aspect of switch. The command is switch port mode access, and basically you're ensuring that those ports can be accessed. So the command is switch port mode access, enter. And then we're going to designate those ports as voice ports or voice over IP ports. So it's switch port voice VLAN 1. And all that is, it's separating the voice ports, putting them in this, although everything else is in VLAN 1, but we're designating these ports specifically for voice VLAN ports. And then enter. All right. And so that's all we need to do on our switch. Go ahead and Control Z out of there. And best practice, I always exit out of any device. And if you hover over the switch, you notice that it's reconfiguring those ports. And it shouldn't take long, but if you hover over it, although it's not going to show you anything, it does show that VLAN 1, yeah, they're already in VLAN 1, so you won't see anything different here.
Wait, it's Carol. Can you go back to that last command line? I'm sorry.
So switch port mode access and then switch port voice VLAN 1.
Okay, thank you.
I think it will show you. We'll get into that later. So now we should be done with the switch. We should have, as a matter of fact, if you hover over your IP phones, they should have an IP address right now. And they should also have the gateway of your router. If you don't have an IP address now, then you've done something wrong. But they should be, and it should be in that range. So my first one is 2, or it was 2. Yes, well now it's 3. And you notice that it will change because that's the way a DCP works. So don't worry whether this changes or not. Just make sure you have an address there because it may do some wacky things, especially with this router.
This is Carol. I'm still having problems with that one, that last command line. For some reason, it's saying it's invalid.
On the switch, right?
Right.
Which one?
The VLAN one?
Switchport voice space VLAN space 1. And you did switchport mode access. You needed the range and all that, right?
Right. So,
Okay. You have to share your screen then.
sorry. There we go. All right, I will do that. Can you see it yet, or?
Yes.
Okay.
Okay, switchport mode access.
Carol, you misspelled switch.
Yeah, you got switch. See? Nope, you still misspelled it. There you go.
Thank you. That's embarrassing.
No, it's learning.
Just blame it on the keyboard.
Yep.
Butterfingers.
Yep. Okay, good.
Thank you.
Yep. Thank you. Who was that?
Jackie.
Jackie. I don't recognize all the voices yet. Thank you, Jackie. All right. Now, well, let me share my screen. So, do we all have IP addresses for our phones?
Yes.
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 Good. Good job. First time. So now we want to configure the phones with those phone numbers so we can actually communicate. So you want to go back to the router, and the router is going to be doing some crazy things. Don't worry about it because the DHCP is active and it's doing all kinds of things in the CLI. So don't panic when you go into configuration. So back into configuration. Yes, this ping conflict, basically it's checking addresses and you'll give you an indication. That's all right. You just have to kind of work around that. That's typical Cisco. So just go ahead and type in your commands as normal. To get to the config, ignore the warnings. That's that tells you that the DHCP is actually running well. So let's assign a phone number. So ePhone DN1 dash DN1. I hate it when it does this. It makes it hard to. So when you type all that in, it should take you to your ePhone DN1 prompt.
How long will it take for this to stop?
It won't stop. So that's why, yeah, it's kind of wacky.
What's the command again? I'm sorry, I missed that.
ePhone dash DN space 1.
And space 1. Okay, thank you.
And yes, just kind of ignore this. And then type in number, and we're going to give it 54001. Enter. So we just assign that number to the first phone. Exit out of that.
I can't even get it to stop. I can't even type anything in it.
No, it's recognizing your typing. You just have to believe that it's that it's working. It's kind of a crazy way, but it's a Cisco thing. And it's the way the DHCP works to ensure that the IP addresses are not creating a conflict, et cetera, et cetera.
What was the next command after ePhone DN1? What was the next?
So we want to ePhone, just number, ePhone dash DN2, enter. And that takes you to the second phone, and then just number 54002. And control Z out of there because it'll drive you nuts. and then exit.
I'm Carol. I can't get it.
Well, you just have to keep, well, if you're not sure, just hit enter and then try it again.
So what's the command again? Is it ephone space DN1?
Yeah, ephone -dn space 1 or ephone -dn space 2. And so after you've done that, you should have your IP address and your phone number.
It says invalid input detected.
Yeah, ephone -dn space 1.
Not happening, Dwight. It's too
Yeah,
fast for me. Freaks me
Mine's
out.
not either.
Yeah, mine's not working.
So I wasn't sure if mine worked, but then when I exited out of the config part and I checked the pop-up for each of the phones, it showed up right.
Right, so you just have to trust that you don't try and beat the display, it just won't work. Just keep typing ephone. And if you make a mistake, it'll give you an error, but it's just a nuance of running DHCP on a router. You normally don't want to do that, but see, it's constantly pinging.
Okay, so what are the prompts from start to finish? We do enable, config,
Yeah, enable and then conf T. So you'll config
conf T. There we go.
But after getting through that craziness, which believe me, I've done that many times, you should have a phone number and an IP address or line number. So now you should be able to go to the phone, lift up the handset, hear the dial tone, and you can actually dial the other number, 54002, and the other phone should be ringing. See the dash is there, or the flash, and it says ring out, and this one says from 54001. You pick up the receiver, they're both connected. Hang up. That means we've successfully configured our voice over IP. And yes, please go ahead and connect this switch to our main switch. And we're not going to try and ping anything, but Monday we will have another challenge based on IP phones and PCs. So prepare yourself for that. And remember, we've set up, I'll just give you a hint, we set up a telephony section. So in essence, no matter what you do, if you have a phone, the network connection should be to this area of your network. Just a heads up. ephone -dn space 1 or ephone -dn space 2. But after you do that command, you type in number and then that 5-digit number. So
if we have problems with this, I mean,
just keep trying.
Right. So we'll watch the video again and then.
Yes, yeah, it's usually the problem is just the commands. The command line interface can be annoying, but some of these devices, it's really the only way, or your switches, except for the new switches, which are more than switches. Anyway, just keep trying, watch the video. But you should be able to arrive at the point where your phone is receiving an IP and your phone has a phone number that's persistent. So that's the goal. And if you don't finish that tonight, make sure you finish our little network, our fourth network, and send it as usual. I'll talk about the labeling here Monday. All right? Any other questions?
Nope, so far so good.
Great. All right, so it's 8:55 now. And I know I worked y'all very hard tonight, almost the whole time. Yeah, so please send me your fourth network. That counts as another part of your engagement and participation. Make sure your phones are connected. And you don't have to send it tonight. Work on this if you're having issues. Yeah, the nuance of the router after you're running DHCP. And the thing of it is, you can't configure your number unless it's being issued an IP. It won't work because the router will not recognize. So you can't unconfigure telephony and try and configure. Yeah, you can't reverse engineer it. I'll tell you that right now. It's just a nuance of the Cisco router. So unfortunately, you have to kind of work your way through that.
And how were we confirming that the phones are up?
Well, the first thing you want to is hover over to make sure it has the phone number that you assign and it has an IP address. And then you want to use one phone, go into the GUI, click on the receiver or handset, and just dial the other phone.
Okay.
And that's the last test. And it will ring. You'll hear a dial tone first. Yeah, that's the first test. That means that everything is configured, is actually connecting, and then you can dial the other phone. All right. Okay. I think I've been a taskmaster long enough this evening. If you have any issues with this telephony configuration, just let me know. It is important that you understand this right now at a basic level, because we'll talk about voice and digital and all kinds of fun stuff as we get more and more into networking. But that's all I have for this evening. Please take care. If you need to meet, to go over some of this, of what we did in Packet Tracer, that's fine. I see that a lot of you have already sent so you're doing pretty good. Anyone else, just let me know. Otherwise, please enjoy the rest of your week, and I will see you all on Monday evening.
Great. Thank you.
Thank you.
Thank you.
Bye.
James looks lost.
Yeah. Well, James, if you want to meet tomorrow or Friday afternoon, let me know. Just send me an email and we can set up a one-on-one.
Okay.
All right.
Yeah. Thank you.
Yep.
Bye.